Hello, my name's Carlos and I'm with,
Carolina Flores, Belén Berrocal, and Cordelia Villarreal.
and today we're going to be presenting on the molecular geometry's effect on the phases of matter.
Well, what is molecular geometry? Molecular geometry is the study of a molecule's three-dimensional atoms arrangements. Molecular geometry helps to identify properties including color, magnetism, phases of matter, polarity, reactivity, and biological activities. It is a 3D arrangement of atoms in molecules. It is determined by bonding and spatial distribution of the electron pairs around the central atom.
So, what are the phases of matter? The phases of matter are solid, liquid, gas, and plasma. A solid has a definite shape and volume. The particles in a solid are tightly packed together and do not move around, just vibrate, therefore having low kinetic energy. A liquid adjusts to the shape of its container but has a fixed volume. The particles in a liquid are less together than a solid and move, but not fastly, and have medium kinetic energy. On the other hand, a gas has no definite shape or volume. The particles move freely and fast and spread, and they have high kinetic energy. Plasma occurs when a gas is given more energy and its electrons are separated from the atom, causing there to be a mixture of free floating electrons and nuclei. And plasma has extremely high energy. Everything we interact with is made up of matter. This is why it affects our day-to-day lives, even though we might not realize it. 3 ways the phases of matter affect our lives are: number 1, plasma is seen in electricity that is used to power our houses every day. Therefore, these utilities include using electricity to cook or make a meal, which leads to experiencing other phases of matter. 2, when we consume the food, we are consuming a solid state of matter, and when we consume water, we're also consuming a liquid state of matter. Both of these are turned into liquids when digested in our stomachs. Number 3, lastly, another great important thing that we need to survive in our daily life is oxygen, which is a gas. We breathe in gas, and our body respires carbon dioxide, being another gas.
How molecular geometry affects phases of matters. Molecular geometry plays a major role in determining whether a substance is a solid, liquid, gas, or plasma. It affects how molecules interact, pack together, and move.
Also,
Intermolecular forces, such as density and phase transitions like melting, boiling, and condensation.
a simple way to put this is that the way that,
Molecules are shaped and arranged determines how they behave in different states.
firstly,
Solids are tight and organized. In solids, molecules stick together tightly because they have strong attractions and fit together in an organized and compact structure,
this makes them
rigid and resistant to compression. This means that they will hold their shape and don't flow like liquids and gases. The way molecules are arranged also influences how hard or dense a solid is, as well as its melting point, which will further be explained in this presentation. Liquids. They flow but stay close. Liquids are a bit more relaxed. Their molecules have moderate attractions, which means they stay close but can still move past each other. This is why liquids can flow and take the shape of their container while still having a fixed volume. The molecular geometry of a liquid affects how easily it flows. This is called the viscosity, and how much energy it takes to boil or evaporate. Gases. Gases are free and expand. Gases are all about freedom. Their molecules have weak attractions, so they move around randomly and spread out to fill any space possible. Since gas molecules aren't held together strongly, they can easily be compressed, and their shape constantly changes according to their environment. Many gases have symmetrical or nonpolar molecular geometries, meaning that they don't have strong forces pulling them together, so they stay in the gas phase unless cooled. Plasma. Plasma is when things get extreme. Now let's talk about plasma, the most energetic phase of matter. At super high temperatures, molecules can gain so much energy that electrons get stripped away. This creates a mix of charged particles. These are known as ions and free electrons. At this point, molecular geometry doesn't matter anymore because the molecules themselves are broken apart and influenced by external forces. Plasma is controlled by electromagnetic forces, which was not covered in this unit.
One way phases of matter relate to another topic is by intermolecular forces. This relates to phases of matter because polarity and phases of matter both use intermolecular forces. So, what is polarity? Polarity affects a molecule's boiling point, since polar atoms tend to have a higher boiling point. Higher boiling points and temperatures result from a stronger intermolecular force because they need more energy to separate molecules. A molecule with a weaker force will most likely be a gas, and stronger ones will most likely be liquids or solids. This all comes back to phases of matter because the point in which something becomes a solid, liquid, or gas is affected by the intermolecular force and polarity.
Moving on to some scientific discoveries that have to do with the phases of matter. First off is Charles's law. Charles's law was discovered in 1787 by Jacques Charles, and essentially what it entailed was that the volume that a gas takes up is perfectly proportional to its temperature, meaning that no matter what type of gas it is, the size of it and the amount of space that it takes up is proportional to the temperature. And this was very significant because it changed the way that we see and understand the gases as a phase of matter. We now understand how much space they take up and how temperatures influence that. And in addition, some of like the real life applications that have to do with this is hot air balloons. Hot air balloons are essentially filled with air that get heated up. And because of that increase in temperature, the space that it takes up is less, meaning that the density is less. And that's why they float, because when something is less dense than the space that's around it, it floats like in water. Also, the Tom Brady cheating scandal is a scandal where some people accuse Tom Brady of deflating some balls, the footballs in a championship, to make them easier to throw. And while some people say that he was cheating, some people also blame it on the fact that the game was played in a really cold day up in Massachusetts. Some people are like, the theory is that the colder temperatures decrease the space that the air takes up and lower the air pressure of the football. Secondly, another scientific discovery is superconductivity. Superconductivity was discovered in 1911 by Heike Kamerlingh-Onnes, and she observed that the electrical resistance of mercury completely went away when she put it at an extremely low temperature. This was at around 4 Kelvin, and the significance was that it exposed the science world to quantum phases of matter, which is a special phase of matter when it gets extraordinary properties from being at extremely low temperatures. And these extremely low temperatures that give it these special properties are used today in many sorts of applications. Specifically, MRI machines use special magnets that are very, very chilled, and this increases their magnetism so that they can see into the body better to get special pictures of the body when these MRI machines are in use. These MRI machines are in almost every hospital, and they save many lives by being able to see into the body in more efficient ways.
This slide shows our works cited. Thank you for listening to our presentation on the effects molecular geometry has on the phases of matter.